Question number 15. I want to actually revisit this topic next year in IB when we have a little bit more math under our belt. So we're going to skip this one for now. And I'm also going to skip this part here. And we're going to actually move into question 16. It's a good question. But we're going to be getting a lot more math behind our physics next year, so we'll be able to revisit this and have it be a lot easier for you to handle. So, question 16. This is a question about satellites, so let's just see. So it says, show that the speed of satellite A is greater than the speed of satellite B by a factor of 2. So the speed that we're talking about, let me add one word here to just kind of refresh our memory on what it is that we do. The speed that we're talking here is the orbital speed. Now, this is something that we covered in class, and I said these are there are 3 things that we want you to come up with when we do gravitational astronomy, planetary motion stuff. When we study universal gravitation, we want to come up with the orbital speed. We want to be able to come up with the value for g, even though that formula is given in the data booklet, and we want to be able to come up with Kepler's third law. So this is clearly an orbital speed question. So let's grab a couple formulas from the data booklet. First, we have gravity force is capital G, big mass, little mass over r squared. And we also have that the centripetal acceleration is given as v squared divided by the radius. So let's put both of these ideas together, and what we're going to see is that the gravity force has the effect of making it move in a circle. So what we're going to do is we're going to compare and contrast satellite A with satellite B. So let's do that right now. So we have capital G mass of Earth times mass of A equals mass of A times v of a squared. And we got to divide this by r of r squared, and this by r, and this cancels, this cancels. So what we're going to end up getting, and you know what, I'm going to move this up just, I'm going to move this over here just so I can read a little bit better. We're going to end up getting that v of a is capital G mass of the Earth divided by r, all under a square root. Now let's do the same thing for satellite B. G, mass of B, over, now it's 2r quantity squared, and the effect is mvb squared over 2r. We're going to have a bit of cancellation. Mass of B cancels here and here. And we're going to end up getting that v of B is gm over 2r under a square root when we cancel everything. So when we compare VA to VB, when they say compare, we can actually do this as a fraction. So VA over VB, okay? I'm going to actually make a note here. You do the algebra, please. And that's going to actually give you VA over VB gives you the square root of 2. Now, at which orbital radius is the gravitational potential due to the Earth the greatest? That we're not going to do. We don't do that in standard level. So we're going to skip this one. Whoops. We'll skip this one. Just fine. All right, now, next question. That's question number 17, and we'll take a look at that in the next video.